G'day, Lockie here. A little over 2 weeks ago, I actually stumbled across a video. I was watching some of the videos from the Monkey Gra conference, and I stumbled across a video from the one and only Luke Marsden, and he has actually gone off, unbeknownst to me, to start a new startup called dotmesh. Now, he was giving a demo on stage about dotmesh, and curiosity got the best of me. I had to actually do an unboxing video on dotmesh. So here is that video. Now, if I was to sum up dotmesh in one sentence or less, it's like Git for your application state. So in this world of microservices and containerized in Kubernetes and in Docker environments, application state can actually be hard to work with. Now imagine a world where we can deal with application state using the same similar tool set as we do with our source code in having a versioning system. So what dotmesh aims to do is actually make your application state as usable and collaborative as our source code tool. So dotmesh aims to do that. So I have actually gone through the documentation, and I'm going to give you an unboxing video. I think it's going to be a lot of fun. Now, you don't have to do what I'm doing. There's great katacoda tools and simpler ways, but I, being the Kubernetes guy, wanted to get it up and running on Kubernetes. Now, I actually stumbled a little bit because I was trying to get it working on AKS, and kudos to the team over at dotmesh, because we were able to jump on a Google Hangout really quickly and get to the bottom of my problem. So hopefully I can contribute the AKS documentation back upstream soon. But anyway, let's get into it. Now, there are a client-side component called the DM command line tool, and there's server-side components that we're going to go install. But if you pop over to docs.dotmesh.com, and pardon me, there's the dotmesh.com website here, docs.dotmesh.com, I'm actually following the install on generic Kubernetes. It's pretty vanilla. I need to update it for AKS, but you can follow along here if you want to do the same thing. So, lovely, we're going to export an admin password and admin API key here called apples and apples. That's great. Apples is to apples. Do some credentials. So it looks like we pump these in and create a secret in the dotmesh namespace. So I'm going to go and do that. Oh, and by the way, I'd like to show you what I'm working with here. I'm running on 1.8.8. This is an AKS cluster. I think it has 3 nodes. I think I spanned it up yesterday. Okay, so we have that. I've done nothing else to this cluster, vanilla AKS. So if you want to check out AKS, go check out the preview there. So I should, at this stage, have a namespace called dotmesh. And what I'm going to do is just put a watch on that thing, cube cuddle get pods, and the namespace dotmesh, so you can see what's happening here. Nothing in there at the moment, no surprises, great. Okay, we've done that. So it relies on etcd under the hood, and this just lays down the etcd operator, so I'm going to copy that. This is going to create a cluster role, and it's going to put the operator in there. Wait for that to come up. Fantastic, we are up and running on the etcd operator there, and we're actually going to lay down an etcd cluster resource, a custom resource, and this should give us a 3-node etcd cluster, I would imagine. So that's working with CRDs, so I've just laid down a CRD of type etcd cluster, and the operator has seen that, and as you can see here down the bottom, member 0, member 1, and we should end up with member 2 momentarily. 3-node etcd cluster, fantastic. So at this point, I'm going to apply a custom version of this YAML that I'm working on. Hopefully I can upstream it so you could use this on AKS as well. But I'm using 1.8. 1.8 is a little bit easier because you don't have to restart kubelet because the volume plugins can be dynamically changed and mounted, whereas in 1.7 you actually have to restart kubelet for it to pick up flex volume plugins. So whoever did that in 1.8 and made that dynamic, thank you very much. But it's the same file, we're just mounting in the location of the volume plugins in a different place. Create-f. Here we go. So what do we got here? We got a whole bunch of RBAC stuff, fantastic. Daemon set, a deployment. Okay, so we have a dotmesh daemon set running. We've got a dynamic provisioner for the volume handling. Okay, so at this point we are up and running, I believe. Everything's running. We're not on 1.7, so we don't have to restart. Now I've already added a remote, and I'm going to just do some fun here. So I actually have the DM version We can't hit the server side yet because I haven't plumbed that in. But what I'm going to do is, you could expose the server so that you can reach it directly, but I'm going to just do a port forward here on port 6969 through to dotmesh. Okay. And I already have it in use because I have it probably running from a previous attempt. So let's go see what I've got here. Okay, so kill that. All right. All right. Don't know what I did with my other window here. All right, that's fine, that's fine. Pump up the font. Okay, and, all right. Right, so what I was trying to do, kubectl port forward, kubectl port forward to that pod, 6969 locally in the namespace .mesh. Now we might have better luck here. Okay, and down here I'll pump up the font size there for everybody else. Okay, so now I would expect to be able to hit the server side. Okay, fantastic. So I'm on 0.3.0 on both the client side and the server side, and I can actually list my dots. So each of these repositories are called dots. So I have no dots at the moment. That's to be expected. So I have just validated that I am up and running. Nothing fancy there. DM remote V, we can actually see these different remotes that I have. Okay, fantastic. I'm going to pop this in the background there. So now, as an application user, I'm going to go over and deploy this hello.mesh application. All right. So it's just a simple apply, but we'll just go through exactly what we got here. Downloads.mesh, and I've got this Moby counter app checked out. There's a bunch of resources in here, but the interesting thing is this one. Okay, so I'm going to edit this because I was playing with this before I recorded this video, surprise, surprise, and I will go through this in a minute, so don't worry about what I'm doing right now. But what I'm saying for this PVC is storage class name .mesh, so there's a dynamic provisioner in here using a flex volume provider that's provided by .mesh, and I'm actually telling it what the .mesh name is. So Moby counter add a branch. So we'll think about this like Git. Irrelevant now, you'll get what that means in a minute, but I'm going to just apply that to the cluster, and this is going to spin up an app, right? So we've got a Redis, we've got a Redis service, we've got a web service and a web app. So let's go take a look at them. Everything's up and running, right? So the dynamic provisioner now, volume provisioner should have created that dot. Fantastic. So we have that dot called Moby counter. We saw that in the PVC. It is up and running, right? So we have a blank app, nothing there, empty. So I should be able to DM commit this branch and just say empty commit. You're going to get the handling connection here because I'm running the port forward there and I'm not grabbing the standard out or standard error, whatever it's logging to. So I now have an empty commit for that branch. And why don't we do this, kubectl port forward. I just want to show you this application. I'm going to put it on 8080 and go back into 80. All right, so this is the web app. Right, as it stands, a blanket web app here, just a blank canvas. So I'm not going to do anything with this, just to represent that we have no state in this application as it stands. So I'm going to do a DM checkout, and I'm going to check out a branch, call it branch underscore A. Okay, so if we do a DM dot show, we can actually see for the admin, so the Moby counter dot, we have dot is current, we are on branch A, master. Now, one interesting thing at the moment is if you follow the Docker or the Katacoda, it actually flips branch and restarts when I do a branch switch, it will actually flip branches and remount the right branch. In the Kubernetes integration now, it does not do that. So what I'm going to do right now is just flip out that state file and move it to branch A. So I'm going to edit the Redis PVC, and we're going to flip this over and bind it to branch underscore A. I'm going to do a kubectl delete on that thing, and then kubectl create -f, and I need to put a dot on this side for the context. Okay, so I'm going to delete and recreate this app is essentially what I'm doing. Watch kubectl get pods. So it's going to go and blow away that app. We're flipping over the volume to this new branch that I've created. We've checked in an empty state on the master branch. Now we're back up and running, and we should be on the other branch. If we do a dm list ls here, we are on branch A at that commit size. Okay, so what I'm going to do right now is we have this web app running, a new version of the web app that we've just bounced and brought back up. I'm going to make some state changes to that app. So here we are with the app. Make sure we can connect. Click to add logos, right? So we've got a web app, we've got a Redis. The Redis has no state on master branch. We've committed Redis with no state. We are now, this just tracks clicks. We are going to put some clicks on here to represent state inside the Redis cluster. And now I, being the good compliant man that I am, I'm doing exactly what they say, which is draw an A. Yay, so I've drawn an A. So all those clicks, all those positional clicks are now in Redis, right? So I've got a state difference. By the way, while I'm going through this, all these commands are actually available here. I've switched branches, I've updated this, draw an A on the screen. I've drawn an A on the screen. Let's go ahead and commit that, right? So now my branch underscore A is at the A on the screen commit. My master branch is on the empty commit. Okay, so what I'm going to do right now is go back and check out master, flip the branch back and rebounce the app. So we're going to do a dm checkout of the master branch. It's telling the dot to go back to the master branch. That should happen. How can I tell that that's happened? We are on master here. We can edit the Redis PVC. We can flip this back to master. Fantastic, we've done that, and we're going to do the delete and recreate. So we can get this watch going again. Isn't this fun? I'm like really excited about this tool. I think it's a really interesting take on how to handle state. All right, so when this app comes back up, I should be at blank. You guessed it, blank. Okay, so because I'm back on master, which has the empty commit. Okay, we're back up. I've just restarted. Da-da, we're blank. Okay, so I'm going to bring that state back one more time. We're going to go through the loop one more time, okay? So, dm switch, checkout, sorry, because we're on that, and we're going to switch to branch underscore A. dm will make sure we're on A. We are on A, so that volume's on A. Now we're going to just switch this over to say please mount. I said volume A before, I meant branch underscore A of the Moby counter dot. Terminology, getting the terminology down. Okay, delete, recreate. Now I would expect I'm on the branch A, which is at the, I've drawn an A on the screen commit. This app should come back up. Yeehaw, it's on its way back up. It is running, we're still waiting for Redis to finish. That's the old version before I did the delete. Everything's back up and running. Kick off that port forward again because I haven't exposed it. Yay, okay. Da-da, right? So just to summarize what I've done here, we have got the Redis state in a Git-like infrastructure here called dotmesh. So I have a repo called a dot, and it has branches. I've flipped between branches and committed different states. Right, so we're on branch A, and I've said this is branch A, I've drawn an A on the screen. So this is great, and it's all done within a single cluster. You could imagine different folks touching this dotmesh installation locally, and this is all open source. Now, what happens if I actually want to collaborate on this? So like Git, I want somebody else to pull it down and run it on their cluster, or run it on Minikube or something like that. Well, there's .hub, and .hub is where I store all these remotely. So just to round out this demo now, I could actually go and log into .hub. I've actually done this piece, and I could just do a push. And somebody else could collaborate. So I could push the state to the hub endpoint, the Moby counter dot on branch A. So that's going to go up and do it. All right. I have some kind of file system with different IDs. Okay. Because I've done this before and I haven't actually cleaned it up, it's going to throw that, but you could go through, this is not a problem, it's my problem, up onto the .hub website and share it and collaborate, so other folks could actually pick it up and be collaborators and pull down that state file. Now, isn't that amazing? So that's kind of where I wanted to leave it. It runs on Kubernetes native. You saw me go from 0 to .hub and .mesh on my cluster, very straightforward. No real magic there, and it just works. So I encourage you to pop over to dotmesh.com, take a look, and let me know what you think. But thanks for joining this unboxing. Cheers.